Hello, what's up everyone? Welcome to the second part of my tutorial, of my series of tutorial videos on how to start developing iOS apps with Xcode and Swift. So this series of videos are for complete beginners, people who want to start developing iOS apps but don't have any prior experience in doing it. And in order to learn how to do it, I'm using a resource actually made from Apple, so a tutorial that Apple released a few weeks ago as of when I'm recording this video, so end of April 2024. So you have the link of the tutorial in the description of the YouTube video. Of course, I encourage you to check it out as you are watching this video. So as I was saying just before, this is part 2. So of course there was a part 1 before. Part 1 was recorded last week and we covered these 2 chapters. So exploring Xcode to learn how to use Xcode. Xcode being the software development tool that you use to build iOS apps, but also macOS, watchOS, visionOS, any kind of apps for the Apple ecosystem. And then we saw how to build a very simple UI using SwiftUI and how to make this UI customizable. Today we're going to see how to build more advanced, more complex pieces of UI, and we'll cover chapter 3, how to lay out and style the UI, probably chapter 4, buttons and state, and if we have time, I would also love to cover chapter 5, lists and text fields, but if we don't have time, it will be for a third video. Before we start, just as always, this is being recorded live. So if you're watching live and you have any question or remark, you have a chat that's available for you. Please write your questions, write your remark in the chat, and I will do my best to try and answer them. That being said, let's actually get started. So I'm just gonna make myself a little bit smaller so that I never cover the code, because the code is the important part in this series of videos. So let's get started, and we're going to start chapter 3, layout and style. So we're going to learn how to design an interface, and we're going to practice putting views where we want them and inspecting their size by building 2 onboarding screens for an iOS app. As you code, play with your own layout, color, graphics, and text to make this project meaningful to you. So I see a few people. Hello from Brazil. Nice to see that we have people watching from another continent. And button and states is where you're stuck at in the playgrounds. All right, so hopefully I'll be able to unstuck you, and it will be just after this chapter. All right, so section 1, we're going to create a welcome page. So we start a new project in Xcode and create a new SwiftUI view. So if you followed the previous video, you know how to create a new project in Xcode. So you open Xcode, you do new project, and you create a project called onboarding flow. So actually I've already opened Xcode. So it's there, so onboarding flow. Make sure you have a SwiftUI interface, all right? I'm gonna put it on my desktop. Okay, the project has been created. What do we do now? I'm gonna hide the preview for now. So I did that by doing Command, Alt, and Return. By the way, that's the shortcut to hide and show the preview. Okay, so then we need to create a new SwiftUI view. So we do Command N here, and then SwiftUI view. All right, how do we call this new SwiftUI view? We call the file welcome page, and then we click on create. So it added a new SwiftUI view, and you can see that we have all of the boilerplate, so the necessary code in order to have a simple SwiftUI view. If I put the preview back, we'll see the preview rendering just the text that says hello world. Yes, we have it right here. All right. So in welcome page, we're going to replace the code inside the body with a title. and we're going to use the font modifier to increase the size and make it stand out. So as I said last week, I copy paste the code because it goes faster and it prevents mistakes from happening because I have to focus on different things. But if you're doing the tutorial, please don't copy paste. Try to write it yourself because it's likely that it's your first time writing Swift code, and it's really important to learn by doing. So please don't do like me. I'm just doing it because I want to save time and I don't want to spend lots of time writing code. It's not the most interesting thing I can do. It's more interesting if I spend my time commenting what I'm doing. Okay, I'm making the preview a little bit bigger so that you can see it. Yeah, something like that. Okay. And they say experiment. You can try out different fonts for your message by deleting the title, so here, and choosing different options from the code completion menu. Notice the different sizes and weights, and think about how you might use the various options in an app. So remember, in order to open code completion, you use the escape key, and you can see we can choose headline, for instance, which is a bit smaller. We have title, a bit bigger. We have also large title, way bigger. We have caption, way smaller. And they all match the role that the label has in the screen. So these different presets for font, it's a way to be able to nicely organize and hierarchize content on a view by making the title bigger. And basically, the more information is important, the bigger it should be. And the less, not really important, but the higher it is in the hierarchy and in the structure of the app, the bigger it should be. And the more it gets like towards the actual content, the smaller it should be. Like you want to have your title to be big and the text of an article to be small, basically, and not the other way around. So then we're going to refine the code by removing the font type name from the argument. So we can actually remove the name of the type where the property title has been declared. And the reason why we can do this is because the font modifier requires its argument to be of type font. You can abbreviate font.title to just .title. This is called type inference. This means that when you compile your code, the compiler is able to infer that here you're talking about the title font. Because since this modifier expects an argument of type font, then it makes sense that this property, you are looking for it on the type font. And so what's happening is that the compiler is going to try and is basically going to say, okay, the compiler says, so this doesn't build, but if I add font, then it builds, and so it's satisfied. Of course, if you were to use something that doesn't exist on font, like title big, for instance, you get an error because this doesn't exist on font and it doesn't exist anywhere that the compiler can infer. But this feature of type inference, when you're new to computer science, it actually seems quite natural, but it's something that was added to programming languages that are used widely quite recently. I mean, I say recently, but Swift is almost 10 years old. But like in the language before Swift, which was Objective-C to develop for Apple platforms, you didn't have this feature. So this is very convenient, but it's also quite recent because like the implementation behind it and the math behind it is not trivial at all, actually. I won't go into the details, but doing type inference, like being able to infer the missing part, it's actually kind of the same thing than filling in the blanks in a mathematical demonstration. It's actually exactly the same thing because of some mathematical property. I won't go into the details of it, but just mentioning it to give you an idea of the fact that it's not trivial at all, especially when you get with code that is way more complex than what we have here in this simple example. Then we're going to emphasize the title using the font weight modifier. So you use type inference here too. So here you can see we just do dot semi-bold and not font weight dot semi-bold, for instance. In this case, Xcode infer the type font.weight. So weight is a type which is nested inside the type font, which is the required type of the argument to font weight. So let's try and write this so that we really see it. So you can see font weight, it expects an argument of type font.weight, and font.weight defines several static properties, and including one called semi-bold. But if we look at it, we can see that they are all static properties defined inside the struct weight, which itself is defined inside the struct, inside an extension of font, which is a way to add stuff to the type font, but after its initial declaration. I see an interesting comment. It says, the little I've read about previous languages to Swift, the more horrific it seemed. So glad to have started with Swift's quality of life. Yeah, and Objective-C was actually improved around like a first time around 2008, something like that, when there was something called I think it was either like modern Objective-C or Objective-C 2.0. There was already like one nice addition to the language which added things like properties and synthesized properties. And then there was a second improvement, which I think was the one called Modern Objective-C, which added stuff like being able to subscript an array. Because originally, in Objective-C, you couldn't subscript an array by doing like angle braces. You would need to call the method object@index. And same thing, to create a static array, you would need to call the method NSArray, array with objects, and then pass a list of objects. It was very roots, very like low level. I mean, back when Objective-C was introduced itself, it was a significant addition on what was before. But that's the thing, like in 10 years or 15 years, Swift might still be there, and it will probably look very old compared to the language that will come after it. But when they introduced Swift in 2014, you can have a look at the video from WWDC with Craig Federighi that is presenting the language. He compares it to Objective-C, and they show like how smaller the code is compared to Objective-C, and it's very similar to the dynamic of UIKit versus SwiftUI. You have this very similar vibe with it, and it's kind of nice to have a look at it just for like it's more of like for historical understanding. But I encourage you to have a quick look at how Objective-C look like. Okay, so and let's experiment. Change the look of the text using the font width or font design modifier. So let's see, what does font width do? So font width, so you can say like compressed to put the letters together a bit more, or condensed, which is a little less closer, or expanded, so they are like further apart. So here I'm less, I mean, knowing when to use each of these width is more of a designer job, and I'm not a designer, so I'm less experimented on when you should use them or not use them. But at least it's good to know that they exist. So we've tried font width, and the other one is font design. This one I've never heard of it before. Oh, so it's like you can have a monospace version. Okay, that's what they call a design. That's great. So monospaced is useful because it means that each character will have the same width, which is not the case by default. You can see that, for instance, the L takes way less width than the C. In some cases, it's nice. In some other cases, it's not what you want. Typical examples are actually the font used to write code. They are almost always monospaced because you want that one character always takes the same width. If you try to write code in Google Docs or in Pages or in like a word processing software, it always feels weird, and that's one of the reasons why it feels weird is because the font you're using by default, like Calibri or Times New Roman, they are not monospaced. Okay, so that's what the design is. So we have monospaced, we have rounded also, okay, which gives like a rounded endings to the characters, rounding like not edges, but like the pointy things at the end. Serif, which adds serif, which is to have this little, well, I guess they're called serif in English, at the end of the character. You know, things that make it feel very much like this is very typical of like trying to make it so you can see it. Yes, like that. This is very typical of written newspaper-like text. Think of the New York Times, for instance. I think the New York Times is written in a font similar to this one. And default, which here would be the without serif version. Same thing. I'm less familiar on when you should use each of these variants, except that monospaced is more appropriate for code, and serif is more appropriate either for things that's written down or for text that wants to feel like something written down. So it's possible that, like in an e-reader app, for instance, you would use a monospaced font. I'm not sure, to be honest. I'm not sure. It's a designer's job, and I'm not a designer, so I won't go into that territory because I don't know enough to give a good answer, or rather a good explanation. All right. So then, section 2, inspect the size of your views using borders. So we're going to explore how SwiftUI lays out views and how modifiers affect layout using the modifier border. A border outlines the area a view occupies. So we're going to wrap the existing body content in a padded VStack by right-clicking and choosing Embed in VStack, then adding the padding. Okay? So right-click on text, embed in VStack. So remember, a VStack is a way to stack several views together vertically. And we add a padding around it. So for now, the padding, I mean, you don't see it because it added extra transparent space, but you can see if I don't have the padding, it stops right at the edge of the W. And if I put it back, then you can see that there is some extra padding. So it's working, even though you can't really see the difference for now. Okay, and then we're going to add a description below the title using another text view and a font modifier of our choice. So here they chose to use font title 2. And so the 2 views are stacked vertically because they are in a VStack. I'm saying it because since they are stacked, since they are written one on top of each other in the code, someone that is a beginner might think that that's the reason why they appear on top of each other, but no, it's because they are in a VStack. If I use a H-stack instead, they are put one next to the other, but in the horizontal direction. So important distinction to keep in mind. So they say once again, try making the description string long enough to wrap to another line, then use the multi-line text alignment modifier to change the way the text is aligned. So I'm just going to copy and paste several times like that. And so it's better like that, actually. Yes, better like that. And so if we do text alignment like that, you can see that by default, it's leading. So align with the leading edge, which is the left edge, because we are using a language which is written left to right. But I could also do trailing and center. So something that you should already be familiar with, because this feature has been in basically every word processing software since like for decades. So I don't remember using a word processor that didn't offer this feature. So I think you already know how it works. I don't need to explain it. But think that there was a time when having this feature of centering the text in a word processor must have been amazing, because before then, like, people were writing text in the terminal and you couldn't necessarily like center the text. So at one point, this was also something straight out of the future. I'm going to put it back to having just description text like that. Then we're going to add borders to the text views, specifying a border, a color, and border width. So a text view's default size is exactly enough to contain its content. A view's default size, it's called its ideal size. And borders are great tools if you're having layout issues or if a view isn't behaving as you expect. Sometimes the actual boundaries of a view don't match the edges of its visible content, like we had before when we had the extra padding, and if you were not aware there was a padding, there wasn't any visual clue to help you see it in the UI. So we've added the black border around the first text, and now let's add the second black border around the second text. Of course, you can change the color, maybe making it like more red, for instance. Totally doable. Okay. And then we're going to add borders to the VStack before and after the padding modifier to see the size of the view with and without its padding. Very interesting approach. So I'm replacing the line padding with what I've copy-pasted. And you can see in orange, the size of the VStack before the padding, and in purple, the size of the VStack after the padding. By the way, when we say the size of the VStack after the padding, it's a bit of a simplification because calling padding returns a new view. So it's not the size of the VStack with the padding, but rather it's the size of the view created by applying the padding to the VStack. We say that it's the size of the VStack with the padding because it matches more what we see visually when we look at the code. But technically, it's important to understand that whenever we call a modifier, SwiftUI returns a new view. So here it returned a new view where we added a border, then a new view where we added a padding, then a new view where we added another border. It's important to have this distinction in mind. I won't go into the details of it, but if you want to learn SwiftUI in more details, I have a series of videos on my channel called Learning SwiftUI When You Already Know UIKit. Actually, it's mostly learning SwiftUI when you already know a bit of iOS. So after watching this series on how to get started from scratch, you can go watch this other series, which goes much more into the details of how SwiftUI works. So we've added the border, and they say that the VStack also has an ideal size, one that exactly encompasses its subviews. And you can see in orange, it's the ideal size of the VStack. What's interesting is that the text has an ideal size because of its content, which is a string, and then the VStack has an ideal size, which is a function of the ideal size of both of its subviews. So we can see that there is this very recursive way of defining how ideal size are computed. Step 5, we're going to complete the welcome page by adding a graphic using a shape and an SF symbol. So we start by adding the shape. So we add a rounded rectangle, which is one of the kind of shapes available in SwiftUI. I'm gonna make the view a little bit smaller, and you can see that it took a lot of room in the screen. I'm sure there is an explanation for this. So if you're using a rounded rectangle, you'll need to add corner radius as an argument. A value of 0 creates a 90-degree corner. Higher values make a more gentle curve. So here I put 30, and you can see if I put 0, it's back to an angle, a 90-degree angle. I think it's called a straight angle. In French, it would be called a straight angle. I don't know if the term is if the word is the same in English. Don't hesitate to let me know. You can see 30 is rounded, 15 is slightly less rounded, and 45 is even more rounded. So I'm going to leave it at 30. And now the explanation of why does the rounded rectangle, so it's right angle. Okay, so in French we would say angle droit, which is also a direct translation. So it makes okay. There was no trick at all actually. It was just like the English, the French word translated into English. Good to know. So why does the rounded rectangle takes so much room on the screen? That's because they say that your shape, so the rounded rectangle, stretches horizontally and vertically to fill all available space because shapes in SwiftUI don't have an ideal size. In turn, the enclosing VStack increases its size to contain the shape. Only the stack's padding prevents the shape from extending to the edges of the screen. So the way this works, I'm going to try and explain with my own words. And once again, you have a more detailed explanation in my other series of tutorials on SwiftUI. It's that what's happening is that when the body is rendered, it can take all of the screen, or rather all of the safe area, so the part that's in purple. Then the padding takes a bit of that space away. So the view that's inside has a little bit less room to render. So you can see that's why its border is in the orange area. And then the VStack is given the space in the orange area. And what it does is that it first gets the size of the views which have an ideal size, so the text here and the text there. and then the size, the space that's left available, it gives it to the rounded rectangle, which says, okay, me, I'm going to take everything. So that's the gist of how the layout algorithm works. The parent view proposes a size to the child view, and the child view says, all right, I'm going to take this size, and the parent takes that into account and proposes the space that's available, but that's left available to the second child view, etc., etc. The only thing is that it doesn't necessarily happen in the order that they were written, because of course the rounded rectangle needs to decide the space it occupies after the two texts have given their ideal size. Otherwise, rounded rectangle would take all of the space available and the two texts wouldn't have any room left to render. And once again, in my other series of SwiftUI tutorials, you have a much more detailed explanation where I take more time to explain this topic, which is a bit more advanced, so that's why I'm not going to cover it in details in this beginner tutorial. But still, it's important to give an idea of, like when you're learning, it's important to learn the basics, but also to know where you should look at when you want to learn more. That's why whenever there is like, I can give you a pointer to learn more, I try to do it. Okay, so step 6, make your shape smaller using a frame modifier. So a frame allows you, the frame modifier allows you to specify the space available to the view. So here we're saying, okay, here you should occupy a space of 150 by 150. And this way, we kind of like, what should be the correct word? We give an indication, we express a constraint to the rounded rectangle view on how much shape, how much space it should take. Then we're going to use the accent color for the shape's foreground style. So foreground style, and then we use the tint color. So this allows us to color it with the tint color, which is blue by default. That's because buttons, for instance, are blue by default in iOS. If you hadn't noticed it, next time you use iOS, and you will see that most system apps, like settings, for instance, they have blue buttons, if I'm correct. Some Apple apps have different color for the buttons. I think, for instance, Apple Music might have more like red-orange buttons, because that's the color of the Apple Music app, actually. Maybe the TV app, the Apple TV app, has white as the color for the buttons because it's very black and white, but I'm less sure for this one. But basically, that's what the accent color is. It's the color for all of the primary actions in an app. And same thing if you've never noticed it, but in an app, all of the primary actions tend to use the same color this way. When you see something of that color, you know intuitively, without having to think about it, that indeed this is something that you can interact with. And mobile apps, they are filled with this kind of like small hints that are dropping at you. So that's one of the things that makes mobile apps very easy and intuitive to use. And actually, oftentimes when you try to design an interface yourself and it's not your job, you make the mistakes of not following these patterns correctly. And then when people want to use your app, it feels very confusing and very like unwelcoming. And that's actually the reason why apps can feel that way. Okay. So next step will be to use padding within stacks. So the amount of space SwiftUI gives views in a layout depends on their order, their types, their modifiers, and other factors such as dynamic type, which is the ability for the user to ask for bigger or smaller text. In this case, the automatic spacing of the vstack puts the title close to the shape above it. You can use the padding modifier to give the title more space. So we're going to add a padding to the title. So like that, and you can see we need to add it before the black border. So like that. So it gave more space around the title, both on the top, bottom, leading, and trailing edges. Let's see. By adding the padding before the border modifier, you can see the boundaries of the text view along with its padding, indeed, because the border is applied to the space occupied after applying the padding. Remember, the order of modifiers matters. Remember the analogy. putting your socks first and your shoes second is not the same as putting your shoes first and your socks second. Same thing here. And we can restrict the padding to only apply to the top edge of the title by specifying which edge it should apply to. So we can say it should only apply to the top edge. Once again, because of type inference, we don't need to type edge.set.top. We can just write .top, and Swift is able to infer the rest. And they say, experiment, the 4 edges of a view are leading, trailing, top, and bottom. Try different kinds of padding on your views to change the design. You can use multiple successive padding modifiers to provide different values for different dimensions. So for instance, we can say, we can provide the value of, for instance, 16. So I'm making the padding bigger and even bigger. Whoa, it was way too much. But you can control both the edge and the value. And you can also do things like top and leading, like that, for instance. Then you can see it pushes the content back to the bottom right corner, or rather the bottom trailing corner. So I will put it back as it is. I really encourage you to experiment with this because it's quite interesting and it shows the flexibility of the padding modifier. And if you look at the signature, it takes as argument the edges, which can be one edge or several edges, and then the length of the padding. Okay, section 4. Use a Z-stack to embellish your graphic. So to add an SF symbol on top of your shape, add an SF symbol on top of your shape using a Z-stack. A Z-stack arranges views on top of one another. So we knew about V-stack and H-stack. Now we also learn about Z-stack, which puts views on top of each other. The reason why it's called Z-stack is because you can imagine on your screen you have the X like that horizontally and the Y order vertically, while the Z-stack is the one that goes from bottom, from back to front. So from back to front. So it's called the Z axis. And so often you can see also the property Z order to say what's the ordering from back to front. And so that's why the view is called the Z-stack. Of course, on an iPhone, this all gets flattened. But for instance, I guess in a visionOS app where you can have a sense of depth, a Z-stack, you could even see the depth between the elements. You could see the depth between the elements being more visible. And also, I'm not sure actually if it works, but I know that on the Apple TV, on some of the buttons, you know that when you have a button selected on the Apple TV, if you move your thumb on the touchpad, you can see the button moving slightly. You're not selecting the next button, you're just moving the button that you are currently on. And you can see that there is a kind of a parallax effect. So I don't know if Z-stack gives you this parallax effect by default in when you use SwiftUI for the TV app. But if it's the case, it would be pretty cool because this effect, like the first time I saw it, I was like, "Whoa, that's super cool!" It gives a very much of a very high-end, very polished feeling. So it's really nice. So we're going to embed the shape, so the rounded rectangle, in a Z-stack. So we do embed, right-click, embed in Z-stack like that. Okay. Then we add an SF symbol to the stack below the shape. So as you can imagine, the order is going to be important. So we can see it's appearing, okay? And then we use the font modifier to make the image larger. Remember that we can do that because SF symbol is actually a font with vector graphics under the hood. Okay, let me just fix the indentation like that. All right, so it's become a little bit bigger, you can see, before and after, like that. So use a system font to set the size you need to make your SF symbol even larger to fit in your shape. So we can actually control the size by passing system, so system for the default font of the system of size 70. So instead of using the preset large title, I do system of size 70. All right. Then let's go back to the tutorial. So then we change the image color using the foreground style modifier. So just like we did actually for the rectangle. So we add the modifier here. We can see it looks much nicer. Okay. And finally, we remove the borders to finish our welcome page. So we remove all of the borders which were just here to help us understand what was happening. So let's see where are all of the borders. So I did Command F to search for border. So border here, 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 and here. No more borders. We're good. Okay. So then we're going to create the features page. So we're going to build a second page to display a list of cards describing the app's features. To keep your views organized on the features page, you'll create two views, one for the page itself and another for the cards on the page. So very similar to what we did at the end of the previous videos. So we're going to create a new SwiftUI view file called features page. So we go into the navigator, create a new SwiftUI view called features page. Okay, what do we do next? We're going to replace the code in the body with a title inside a padded vstack. So we copy and paste the vstack like that. Okay, so we have the title, the vstack has some padding. All right, what's next? Then we create a new SwiftUI view, so second one, and we created feature card. And we create a SwiftUI view file, not just a new view in the same file, we create a new file. And we call it feature card. Then we add two properties to feature card, all right? Okay, like that. So for now, no changes in the view. We have a build error because we need to provide actually values for the icon name and the description. I see a message in the chat. So what does it say? Bonsoir Vincent, from across the pond. Just wanted to offer some appreciation for what you do, putting out Swift into Swift in info and streams so consistently in such an unthankful world can be easy. So merci. You are very much welcome, and I really hope that this series of tutorial is going to have an impact. I saw that Apple is really happy about their tutorial to the point that they actually run ads on Reddit apparently to promote the tutorial. So I hope that they will enjoy also that I use them. But I really hope that these videos will help people that are on this journey of getting started with Swift and iOS. And thank you for sharing your appreciation. It's very much appreciated on my end. So now we need to solve the build error, and if you followed last video, you already know how to do it. But let's see what the tutorial is going to tell us. So we're going to fix the instance of feature card in the preview by adding string arguments for both the SF symbol and the description. Make sure the description is long enough to occupy more than one line of text. And they say you can use the fix button in the error banner. So this one right here, the fix button. And if you use it, what does it do? What do they say? They say that it will add necessary arguments, but because you aren't using the properties in the views body yet, you won't see any changes in the preview. So let me copy and paste the code and put it back here. So like that. Okay, I'm going to hide it here, split across several lines. Remember, it's Command M, Control M to do that. Okay, and so here we have the preview like that. Okay, so it didn't change anything because we are not using the icon name or description inside the body. But of course, that's going to change because we're going to use them just after, I guess. Yes. So in the views body, display the SF symbol using an image view inside an H tag and use the icon name property as the argument. So copy and pasting. So I replace the text with this H tag. And inside we have the image. We can see it right here. So the image which shows two persons, crop square stack fill. So the name of the SF symbol that we are using. Remember that there is an app that you can use if you want to browse across all of the existing SF symbols, and you can download it from Apple's website. Okay. Did we add the large title? Yes, we did. Then we add a text view to the h tag to add the description, and we use the description property as the argument. So it's going to add this quite lengthy description. Okay, we can see that it goes onto the second line. So it's a multi-line description about a feature paired with the image on the left. Okay. Then we add a colored background using a rounded rectangle. So for this, we use a new modifier which we haven't used before, which is the background rectangle, and I apply it at the level of the h tag. So you might be wondering, it's weird because last time we used the rounded rectangle without specifying a frame to it, it tried to take all of the space available on the entire phone. But this time, it doesn't seem to do that. Why this difference? The difference is that before we were using a rounded rectangle inside a VStack and a ZStack. And both the VStack and the ZStack were allowed to take as much space as was available on the screen. Technically on the safe area, but I'm simplifying a bit by saying the screen. Here it's different because the modifier background is going to the modifier background is going to only offer to the rounded rectangle the space occupied by the view the modifier has been applied to. So for instance, if the h tag only takes that much space on the screen, then the background will only be able to occupy that much space. So that's why there is this difference. If we had used a ZStack instead of the background modifier, it would have been very different because in the ZStack, the rounded rectangle would have been able to take as much space as was available in the screen. Here, because there is no other parent view that could limit the space available. So that's a very big difference. I see a great question. Is the comma after tint necessary even when on its own line of code? Yes, it is necessary. If you forget it, the code won't build. The reason why it's the case is because of something that's called the grammar of the language, which is basically the set of rules that says what's a valid Swift syntax and what isn't one. And if you look for the grammar of how to call a function in Swift, you will see that every argument except the last one needs to be followed by a comma. So even if it's on a new line, it doesn't change anything. To say it otherwise, the fact that it's on a new line or not doesn't make any difference in the semantics of what you've written. It's purely visual, but for the Swift compiler, it's actually the same thing. And indeed, the reason is because there is another argument after this one. Now, don't get me wrong. When I say that the new line is ignored, it doesn't mean that that new lines are ignored by Swift. For instance, if I put a new line here in the middle of the identifier, you can see that it does have significance because now Swift is confused and it's very different to write back new line ground than to write background. That's very important. So in some places, adding return to a new line has an impact on the syntax. In other places, it doesn't. And more generally, Swift isn't a language that uses new lines and indentation for the syntax of the code. There are languages that actually do that. Typical example would be Python. In Python, you do indentation. The indentation is used to know the scope of the code. In Swift, we use curly braces for that. So it's more some language have this philosophy. Swift doesn't. But very good question. Thank you for asking it, because it's a typical kind of question that when you're a beginner, you might ask yourself. But me, it's been so long since I've been doing like computer science stuff that I've become so accustomed to it that this question or this remark wouldn't even have come across, you know. One thing that's interesting, and I'm going to mention it more as like an exercise to the reader, but if you add an extra comma at the end of a function call, so after the last argument, you get an error. This is not a valid syntax. There are languages where this would be a valid syntax. However, in Swift, if you define, for instance, an array, so like that, so like an array 1, 2, 3, like that, so you have this array, you split it across several lines. When you have an array, you are allowed to add a comma after the last value. This is valid. There is an error here for another reason, but this is valid. So having a trailing comma is valid when you declare like literal collections, so arrays, dictionaries, but it's not valid when you are passing arguments to function. I won't go into the details about why it's not valid for functions. I'm not 100% sure, but I'm pretty sure it's linked to the fact that Swift supports functions which are called variadic, so functions that can take several arguments. I think that's the reason why. Arguments that can take more than one value. So if you want to learn about these variadic functions, look it up. I won't go into the details of it, but I think that's the reason why trailing commas are not supported for the last argument of functions in Swift. And now I think it's high time that I go back on the topic of the tutorial. And yes, the upside of Swift not using spacing and stuff like that for the syntax is that a bad formatting cannot ruin your code. Yes, that's a very good point. It's very easy in Python to put some code outside of a for loop, for instance, and not realize it. So that's a very good feature of Swift. Personally, it's more like it's personal preferences. Some people prefer one over the other. Personally, I kind of prefer like the safer way of Swift. Back to the content. Then we add a white foreground style to improve the contrast of the card because it looks a bit weird. And interestingly, you can see that we add the foreground style to the H tag. And then it gets distributed kind of magically to all of the views inside the H tag. So I'm not sure that the tutorial will go into details of why it's the case and how it works under the hood. So I'm just going to say the keyword in case you want to learn more. But what it does is that it injects the value white color for the key foreground style into the environment. The important word here is environment. If you want to learn more about how this modifier called on the H tag can have an effect on the image and the text, even though the call of this modifier here is unrelated to the declaration of these two views, is because we have the environment, which is a way for SwiftUI to pass values from a parent view to a child view. I won't say more, but you can learn more about it if you search on Google. And once again, it's also covered in my SwiftUI training course, which is available for free on YouTube, in my more advanced SwiftUI training course. Then we're going to give the card's content some space by adding a padding modifier to the H tag before the background modifier. So adding a padding is usually kind of a good practice, not gonna lie. Okay, it looks much better. And then they say use the navigator to switch to the features page file, then add a feature card below your title, and use an SF symbol and description of your choice. Me, I will just copy paste because I'm super lazy, of course. So we go back to the features page. We can either do it by clicking here if the file was still open. Otherwise, here on the navigator, we go into features page. And so below the title, we add the features card. Let's split across several lines like that. Okay. Then they say add a bottom padding to the header text to separate it from the card. So we add a bottom padding like that. Okay. Then we add a second feature card with a different icon and a shorter description. Testing with different icons and descriptions will ensure your feature card can accommodate different content and still maintain its design. So basically testing you will often see the term edge case in computer science, and edge case, sorry, I meant to do Control M. Edge case, it's testing like the kind of like values that are at the edges of the domain of possible values. So for instance, text on one line, text on a lot of lines, text that is very short or very long, this kind of different possible values. So it's kind of nice looking, but you can see that it would be better if both blocks had the same size, because here it feels a little bit weird. So I guess that's what we're going to fix just after. Let me just make the code a little bit nicer before. So the card with the shorter description doesn't fill the width of the screen. If you switch files to fix the card view, you won't see the second card you just added. So click the Pin Preview button in the top corner of the preview panel so you can see both cards while you edit your code in another file. So we can pin this preview here, and then when we are inside the other file, we will get access to the pin preview. We can still get access to the preview of the current file, but also the pin preview. And I think the fact we can access both was added in Xcode 15, because I think before there wasn't this nice feature, like you could only see either the pinned or the current one, but not both. And it's really nice to have the choice. And tip: when an app contains many views, you can pin a few key previews to minimize switching back and forth. So you can pin more than one preview, which is very useful. So then we select feature card in the navigator, then add a spacer to the end of the stack, of the H stack. This shifts the rest of the card's content to the leading edge and makes the card occupy the full width of the screen. So what are spacers? Spacers, they are a special kind of views that expand as much as possible to fill empty space in the direction of their containing stack. So in an H stack, a spacer will fill horizontally, and in a V stack, a spacer will fill vertically. And so experiment, try moving the spacer to the beginning or the middle of the card, or try adding more than one spacer. So here we add a spacer here at the end, and it's a way, you see, to fill the empty. It pushes the content to the left, but it's more of a consequence is that it takes all of the space available, and because it does that, then the content gets pushed to the left. And so if we move the spacer like that, you can see here in the middle and here at the beginning. This is dirty, this is better. So let me put it back. I see an interesting question. Is there an equivalent to spacer in UIKit? So two answers to that. There is one, but not in UIKit as you think, but you might know that when you use UI tab bar item, actually, UI tab bar item is not a subclass of UI view, it's just an object. And you have the flexible width in UI tab bar item, which technically is the equivalent of a spacer. And sometimes I've said in my other SwiftUI course that UI tab bar item was kind of like a simplified version of SwiftUI because it was a declarative syntax to build a small part of the UI, so the tab bar, inside UIKit. So that's more for the joke that I'm mentioning this one. And no, you don't really have an equivalent of the spacer in UIKit, but because in UIKit, what you would do is that you would say, okay, this label, you would constrain its trailing edge to the trailing edge of the parent view, for instance. So that's what you would do. You would have a parent view actually here, and you would say, okay, this parent view is constrained to the leading edge constrained to leading edge of the parent view, etc., etc. So you would do things like that by constraining the edges. So there isn't really the equivalent of a spacer, to be honest, in UIKit. If someone has a better answer in mind, and I missed like something, please say it in the chat. But I don't think there is one, because when you have constraints, you don't really need spacers. And spacers are kind of here because without constraints, like in UIKit, you need a way to express declaratively the fact that you want something that will take all of the space that's available. If there are people that come from the Android world, I know that when I did a bit of Android almost 10 years ago, you could say whether a child view should wrap its content or match the size of its parent. And so that was kind of like an equivalent of adding a spacer in a way. There is an alternative to spacer also, which is to put a frame and say the frame should have a max width of infinity, for instance. I will let you read on this more advanced technique if you want to look for alternatives. But there is a great video from the YouTube channel Flo Writes Code on this. and it's very interesting. I think like the thumbnail is like a spacer with a forbidden sign on it. It's a great thumbnail, and the ID cover in the video is really nice. And you're saying so. Wicked, thanks. Yeah, I've struggled to ensure elements are spaced properly in UIKit, but that's encouraging. I'm doing the right thing currently. Yeah, and if you want to do the same thing with a VStack in UIKit, it can be challenging. The way you would do this in UIKit would be also in UIKit, you have this idea of compression resistance, and you can use it to say, okay, when there is space available and there are two views inside a subview, which view should expand or compress in order to accommodate when there is more room or less room? But it's quite a confusing syntax, and it's way more difficult to maintain than just having a spacer. Spacer has the advantage of being very clear when you see it. The meaning, the intent is quite clear. And so that's a big advantage of spacers versus their equivalent in UIKit. And so now that both cards are full width, make the icons occupy the same width by adding frame and padding modifiers to the image. So frame to say same a width of 50, and padding to say we add a trailing padding or a padding to the trailing edge, so like that. Looks better indeed. All right. And you can provide any combination of arguments to the padding modifier, edge, size, or both. We saw it a bit before, because both parameters have default values. Let me show you actually. But indeed, by default, the value for the argument edges is all edges, and length is nil. Be careful, nil doesn't mean 0. That's something that can be so tricky, because HStack and VStack, they also have a spacing property that you can specify which is an optional CG float and with a default value of nil. Nil doesn't mean 0. Nil means that SwiftUI will use the most appropriate value depending on the context, and often it will be 8 points for the padding, for instance. But nil here is different than 0. If you specify 0 for the padding or the spacing of the items in an HStack or a VStack, it will be very different than specifying nil. And I've seen people, even very experienced people, get caught off guard by this, especially with VStack and HStack being like, I don't understand, there is a margin, I don't understand where it's coming from. It's because you would need to do spacing 0 if you want to have a spacing of 0. By default, the HStack might apply some spacing in order to have something that looks best and that is aligned with Apple's human interface guidelines, which, if you don't know about it, it's a page on the developer website which lists all of the best practices to build an iOS UI that actually looks like an iOS UI. So if you wondered the rules that Apple applies when building their own apps, they're available actually on Apple developers website, and it's something called the Human Interface Guidelines, and you can often see them being abbreviated as HIG. There's even a shortcut in Xcode, which I have forgotten about, but when you type it, it opens the Human Interface Guidelines in Safari. Maybe it's Command-Shift-H. Yes, actually I remembered it. So it's Command-Shift-H, and it opens the page with the guidelines. Nice to see that they've put a shortcut for it inside Xcode. Okay, section 6. It's actually quite a long chapter. So section 6 is combine screens with tab view. I think we did that a bit last week, but we might have done it, but very briefly. I'm not sure. But maybe we covered it. Anyway, we'll cover it this time. Anyway, so to create an onboarding experience where people can swipe between pages, use a tab view. Like other container views, tab view contains multiple child views, but a tab view doesn't display them all at once. It shows one view at a time and gives people a way to switch between them. Oh yes, I think we use a tab view by default where you have tabs button at the bottom to switch between one tab and the other, and here we're going to use another very cool use case of tab view. In iOS apps, a default tab view displays tabs at the bottom of your screen. So most apps from Apple, for instance, work like that. Think about like the music app, for instance, or the clock app. They both follow this pattern. You tap a tab to display the corresponding view. In this example, you'll modify that behavior with the tab style modifier to swipe between the two pages instead. And it gives you a quite powerful behavior with way less code than would have been required in UIKit. So select content view in the navigator, then unpin the preview for features page. So we go back to the content view and we unpin the preview for the features page. Okay. We replace the body, the code of the body in content view with a tab view containing the two screens we've built, welcome page and feature page. And you can see we've put the tab style, the tab view style page for the tab view. Okay. And so the page tab view style lets you swipe left and right to change views. To see the tab view in action, click and drag in the preview. So like this. And it's quite neat how easy it was to build. I can tell you, like, actually, my first paid job after I graduated as an iOS developer was to build a view like this. And I had to build it in UIKit, I think using a scroll view. I don't know if it was a scroll view. No, I think it was a collection view, but with some kind of stops, so that like when you would let go, the scroll would stop only on certain points, certain coordinates you had allowed. And building it in UIKit took quite a bit of work. Whereas look at this, like it's built like automatically. Even auto-magically, we could say. That's quite nice. That's quite nice. That's one of the killer features of SwiftUI. Like one of the big pain points of UIKit, if you've ever used it, was building scrolling content. It was a freaking nightmare, and so SwiftUI is able to handle it so much better. In part because of this notion of ideal size and the fact that SwiftUI knows the size of the things it's displaying. That plays a big role. And yeah, they call it tab view, but basically it's a page view. And interestingly, this component in UIKit, one version of it is called the UI page controller, I think. And the UI page controller, it was, if you've ever used the iPad around when it was released, the iPad when it was released had this feature, especially for like ebook apps, where you could take the page and turn the page by swiping, and you would see like the page like curling and going to the other page, and the text would wrap in a realistic way as the page would curl and follow the movement of your finger. It was super impressive, and it was actually built into UIKit. It was an option on this UI page controller. So if you have used iPads between like they advertised this on the first versions of the iPad. So like if you were lucky enough like me to have an iPad when it released in 2010, if I'm correct, you probably remember this behavior, and it was called the curl, the curl, I think, style for the transition. And back then it was mind-blowing. Seeing that it was rendered at 60 FPS, super like fluid and everything, this was absolutely mind-blowing back then. Yeah, you remember that effect from the Books app. I think, to be honest, anyone that had an iPad remembers this, because it was the thing that made it feel so high-end, and it shows that to give a feeling of being very high-end, you don't need to have a lot of things. You need to have one thing that you do really, really well and that you market a lot, and it does the job, because like 15 years later, we both remember it. Actually, I remember that the iPad, released 15 years ago. No, 14. Yeah, 14 years ago. It was in April in the US, and a bit later, it was in May that it released in France. So 14 years ago. Okay, so that was actually quite fast to add the tab view. Then we're going to add some colors to make it look nicer. We'll also add this little like page controller at the bottom. So a page tab view adds a white indicator at the bottom of the screen. Actually, apparently they are there, but we just can't see them. Let's see. And they are not being shown, but okay. Apparently they are there, but we can't see them. Maybe if we switch to dark mode. Oh yes, now we can see them. Perfect. So I will go back to light mode because dark mode is not always great when the video is encoded during a live stream. But okay, they were here, they were just not visible. So how do we make them visible? We're going to define custom colors. So we're going to look in the list of files navigator and select something called assets. So let's have a look and see what is this asset thing. So it's this thing here. It's what's called the asset catalog. It's where you store images and colors, all of the graphical resources that your app will consume. And the reason why you put it into an asset catalog and not just like files put inside your project is because the asset catalog it allows you to give meaning about when to use each asset. You can say, for instance, you have a specific asset for light mode and dark mode, these kind of things. And also, when you build your app and when people download your app, they only get the assets that make sense for their iPhones. Like if they have an iPhone that has a display with more or less higher or lower density of pixels, they don't use the same icons, and it doesn't make sense for them to download the versions of the app that the device will never use. So that's why we have these things called asset catalogs that were not always there. They were introduced around iOS 5 or 6, something like that. At the beginning, we didn't have them. We just had PNG files like in our project or JPEG files in our project, and that's how it was done back then. So we're going to use the plus button at the bottom of the assets to create a new color set. So here, plus color set. We change the name of the color to gradient top. So it will be the top color of the gradient. And then we show the inspector by clicking at the top right of the window and choosing View Inspectors, Show Inspector. So here, and we have several inspectors. I don't know which one we will use. The last one, okay. In the inspector, next to appearances, click and choose None to use the same color for both light and dark mode. So where do I do that? So appearances, so None, it means that we will use the same color in light and dark mode. Then select the color swatch label universal, so like that. In the inspector, use the controls below color to define a color. If you want to match the project screenshot, use these values, so red 0.852, green 0.646. So here I missed it, but it was, it's because, yeah, so it says point in the tutorial, but my computer is on the French local, and we use a comma to separate the decimals, so that's why. And also I'm realizing that I'm hiding this part. So you can see, so for me it's comma 852, but for anyone else it will be point. It's interesting to see that this part of the UI is localized, whereas like the rest, Swift code isn't localized. Like you always put a point to separate like the decimal part of a number in Swift, but this here it uses the preferences of macOS. So that's kind of interesting. Okay, and then here it's 0.847, I think, like that. Okay, seems to be correct. All right. Same thing for gradient bottom. So we'll see if I can go a bit faster this time. So I create a new color. I call it gradient bottom. You can see that I cannot put it after because it's ordered alphabetically automatically. So of course I could cheat by putting like a Z. No, that doesn't do the trick. I could do like gradient like gradient like 2, or I could add something to say that one is at the top, one at the bottom, and to put them in the same order. Here, it's not too much of a problem that they are not in the same order. So here it's 0.954. So remember, same color for light and dark. So 0.954 like that. Then 529, and 385. Okay, we have our color. All right. Then we open the content view file and declare a global property for the gradient colors at the top level above the declaration of the content view struct. Okay, so back to Xcode, moving the window back where it was. So content view, and we add this at the top of the screen. And let me hide all of the inspectors. What do they say? They say that a global property is visible to all of your code in all files, so you're not limited to using gradient colors in content view. The value of gradient colors is an array of two colors. An array is a collection of type that can store multiple instances of one type, such as color, string, or int. Xcode creates a camel case color value for each custom color set you define. So this means that you can see inside the asset, I've defined the name of the color, and it automatically, so Xcode automatically created the code to have these two nice identifiers to refer to the colors. Before that, you had to write to pass in strings with the name of the color. That was very error prone. What's nice with this is that if I make a mistake in the identifier, I get a compilation error. For instance, if here I make a mistake, so let me build the project again, because you need to build once so that the identifiers are created. But you can see that if here I put an extra P, for instance, I made a typo, I have an error because there is no such color. If I remove it, it builds successfully. And same way, if here I rename the color, then code that uses the old identifier won't work, and I will need to update the identifier. So this is what compile time safety does. It's a very desirable property because it makes your code much safer, because if there is an error, it gets caught at build time and not at compile time when your user is using the app. And you want to catch errors as early as possible, and catching errors at compile time is great. And so by doing this, basically, you rely on the compiler so that it enforces the fact that all the colors that you're using are valid. And that's quite nice because it alleviates for you the need to worry about it yourself. Remember when I was saying that you can add an extra comma at after the last element of an array? Case and point, yes, you can do it. I was able to successfully build my project even with this extra comma. Yes, exactly. We've capitalized it in the name of the color in the asset catalog, because it's more of the convention to write it like that. But in code, it's more the convention in Swift to start with a lowercase for the first word of an identifier for properties and methods also. And so that's why here it's a lowercase character. Types follow a different convention because types, they start with an uppercase even for the first word in the identifier. Very good question. Okay, so, and by the way, global properties like that, they are not great because yes, they are usable everywhere, but they're all in the global namespace and it's not great. So usually what you would want to do, you would, for instance, want to put it inside a struct that you would call, for instance, a struct that you would call colors. And then you would do colors. I mean, colors is already taken. No, the name colors is available actually. Color is taken, not colors. You would do then colors.gradient colors. This way, gradient colors, it's scoped inside a type. It gives more meaning about what it does, and it's a better practice. Putting stuff inside the global namespace is not seen as a good practice. Here it's okay because it's a constant. If it were a variable, it would be really bad. Like global variables is a really bad practice in general in computer science. Global constants is slightly less of a bad practice because since they are constants, they cannot be changed, and so you don't run the risk of having a part of your code changing something that breaks something at the other end of your project. But still, it's not the best practice. So don't do this at scale in an actual app. And then we add a background to the tab view. So using once again the background modifier, and this time we don't pass a rounded rectangle, but we pass in a gradient, which is a view that will render a gradient and it will also take as much space as available to it. And so you can do swipe to see your background on both the welcome page and the feature page. because we've added the background to the tab view. And you can see indeed, what's nice is that you can see that the background doesn't move because it's the same background for both actually. If I had put the background individually on each of the tab views, you can see that, I mean, it wouldn't take all of the space available because the welcome page and the features page, they don't take all of the space in the screen, but you can see very clearly that here it's two different backgrounds in the eyes of SwiftUI. Whereas here, since we've put the background on the tab view, then it's actually the same background and we have two views that are sliding in front of it. I wanted to make sure that you understood that distinction. Okay, section 8. Create a theme color and polish the style. So choose an app accent color that fits the color scheme of your app, then modify the text and backgrounds of your views to enhance the style. So in content view, apply a white foreground style to the tab view to change the color of the titles in both views. So we apply it just after the tab view style, and then you can see foreground style white, so it made text go from black to white. Okay. When you apply foreground style to a view, the color will cascade down to all subviews that don't set their own foreground style. And remember, this is thanks to something called the SwiftUI environment. Then select Assets in the navigator, then select accent color to change the accent color of your app. So you can see there is already a space for it. So by default, it's the blue, but we can set a different color. And so select universal, then edit the color in the color section of the inspector, so like we did before. And this time the values are 0.269. So let's do that. So it's going to be a color, a custom color. Should I choose sRGB? Yes. So if you want to learn the difference between sRGB, DisplayPrefree, etc., look for what is a color space. I won't go into the details of it because this is quite complex, and I'm not gonna pretend like I know all of the intricacies of it, but it might be worth having a look at it. Okay, so 0.269, 0. You can't see the other thing, but me, I can see it. So this way I can win some time. 0, 6, 4, 7, something like that. Let's move the window back. And then to see the new accent color in your app, select the content view file and look at the graphic and the features card. So if I go back to the content view, you can see indeed the color has changed. It used to be blue. Now it's this very muted purple color, and same thing here. I see a good remark. Most of this can be hand-coded as well, or does Swift require the Xcode Asset Manager to use these constructs like accent color? I think you can override it in code if you want. The accent color, I'm less sure of how you can do it, but I'm pretty sure that actually, I think you can go in your app like that, and at the top level of your app, I'm sure you can do something like, yeah. So, okay, it's defined on view, but on the top view of your app, you can do like accent color. Okay, now they've changed it, so now it's tint, but you can change the tint like that. So you can also do it in code. And so if you're using Playgrounds, so you say that you're using Playgrounds. Playgrounds, it's an app on iPad that allows you to build iOS apps. Actually, you can go all the way up to submitting your app to the App Store. It's actually surprisingly good. I did a video like 2 years ago on how to build an app for using Xcode Playgrounds. So I did a live stream actually 2 years ago, so you can check it out if you want after. And yeah, Xcode Playgrounds on or rather it's Swift Playgrounds on the iPad that supports building an iPad app works quite well, honestly. I was very surprised by the quality of it. And what's funny is that in Swift Playgrounds on the iPad, you have a feature to generate an app icon automatically with like some presets, if I remember it correctly. But so you don't have a way to do the accent color with Asset Catalog. So it's interesting to see that there is one thing in the playgrounds which isn't available in Xcode, and vice versa. Nice to see that there is no feature parity, but one isn't even the subset of the other. And so now let me get rid of the code that I might have written because I don't want to forget it. Yes. Okay, so this goes back and we go back to content view. Okay. Step 5, select the features page file, add your background color to the preview so you can see how your accent color will look in the finished app. So yes, because since we added the background, there is a good point. Let me go back to Xcode. So we added the background here on the tab view. This means that when we are designing the features page here, we don't see the background, but we need to see it in order to be able to gauge whether our view is readable and looks nice. And so the way we can do it is by defining it here inside the preview. And this way we can see we have the background displayed. Here it matches only the space, the ideal size of the features page. That's why it doesn't take all of the space available. We'll see if they show us how to fix it. So and then they say to do the same thing with the white foreground style. So here I think they show it to show us like how you can customize the preview in a real app. This I'm not sure that I would want to duplicate the code. I would try to have the code only in one place. I think that would be a better approach than trying to duplicate the code, because it's very easy to then change it in one place and not in the other. But at least it's good to see that we can customize the preview. And then they say, so the features page preview doesn't extend to the full height of the device frame, like we see here. I make it a little bit smaller, like that, because its VStack tightly hugs its content, because the background only uses the ideal size of the view that it's been applied to. Extend the preview vertically by requesting infinite height. And so you do it by doing frame max height infinity, like that. You might had in mind another solution, which would have been to put a VStack and then a spacer before and a spacer after. This probably would have given a similar result. And when I was telling you that you can use a frame with max height or max width infinity instead of spacers, that's an example of how you can use it in practice. I see a question. Preview contents that just for the editor, it won't show during runtime on device. Yes, absolutely. And anything that's inside this preview, it gets stripped by Xcode when it generates your app. So not only it will not run on device, but also it will not even be part of your app when you ship it. On the other way, I think it's possible to run the preview on your device on Xcode if you want to check it like that. I don't remember how to do it, but I think it's possible. You do it by clicking here, and if you have an actual device plugged into your computer, it will appear. I don't have one plugged to my computer right now, but I think you're able to do that. Okay, let's see what we will do next. Now they talk a bit about this modifier. So as opposed to frame width, height, and alignment, which we've used before, where we were giving actual values, you can use this variant, so where you say max width, for instance, to specify a flexible frame. You can skip the arguments you don't need. Here you only provide a value for the max height. And if you look at all of the arguments which are available, you will see that actually, you see, min width, ideal width, max width, min height, ideal height, max height, alignment. You have quite a few of them. And since they all have default values, well, you have 1, 2, 3, 4, 5, 6, 7 arguments. This means that there is 2 to the power 7 combinations. Actually, no. Since you can also pass, pass in, it takes it into account. So there is 2 to the power 7 combinations of ways to call this function with different arguments being provided, and for the others you rely on the default values. So that's quite impressive when you think about it. And actually, if you click here on the little like disclosure indicator, you can see all of them being rendered. So it's nice that Xcode doesn't like hang or crash, because as you can see there is quite a few of them. There is quite a few of them. 2 to the power 7. I don't know how it is if you want to do the math on your end. Should be like 2, 4, 8, 16, 32, 64, 128. So that's quite a lot, and this grows exponentially. So as you have more and more, if you have like a function with maybe like 15 arguments and each of them have a default value, and then you click on this button here, I don't know what happens. I think when I want to try it one of these days, but it's kind of like, there is a video of someone taking the Apple Watch and then using an electric drill to turn the digital front so that the views get smaller and smaller and smaller. It's kind of like the same idea. Like it's gonna give a very weird thing. Back to the tutorial. Step 8, set custom spacing for the VStack. I mentioned it just a bit before. So you can set custom spacing and alignment for all VStacks. Try out different values in different stacks in your app to see the effects. So for instance, they say we should set a spacing of 30 here for the VStack. So by saying spacing like that of 30. And we can see that there is more space now between all of the views. And the other thing is called alignment. So by default, it's center. You can put it leading. And if I put it leading normally, so I just need to put the argument. I don't think I put them into the right order. Yeah, alignment is first. So alignment like that. So by default, alignment is center. But if you do leading, you can see that normally, what's happening? Alignment, spacing, because I can't spell, that's why. So by default, it's the center alignment, but you can do leading, for instance, and you can see now it's aligned on the left. And once again, I go into much more details of how these values work in my more advanced SwiftUI series of videos available on my channel. And I even cover how to create custom alignments, which you can do. It's quite complex. It's a very advanced topic, but it's possible for the more complex use cases. And so here we want to do a spacing of 30 like that. Okay. Step 9, use a spacer to push the contents to the top of the screen. So we put a spacer at the bottom so that the content is pushed back toward the top of the screen. Okay. And to keep the contents away from the very top of the screen, add some padding to the title. So a padding of 100 at the top. Interestingly, I was about to say I would have put the padding, maybe I would have put the padding on the VStack. Is there a difference? No, doesn't seem so. Instinctively, I would have put this padding on the VStack rather than on the text. It feels more like the responsibility of the VStack, to be honest. But at least it does the job. And if you need to implement like a UI that your designer defined in Figma, you will find yourself like setting this kind of padding on specific edges quite a lot in order to position things on the UI. And yeah, the alignments are quite interesting to experiment and try on. And what's interesting is to try and see like just up to when you can go with the default alignments and when is the moment when you need to rely on custom alignments. Like what cannot be implemented when you use just the custom like leading, center, and trailing alignments. And by the way, VStack has a leading, center, and trailing, and an HStack has top, center, and bottom, of course. And these stacks, they have like the same, they have all of the combinations. So they have leading, trailing, top and bottom, and also leading top, leading bottom. So they have like all of the possible combinations you could hope for. Okay. Now they say pin the features page preview. So let's do that like that. so you can see it while you make edits. Then open the feature card file and change the background modifier to use a custom view. So feature card, okay. So here, and so here we're going to say, so yes, that's what we have here. So, oh, this, okay, we do something different. Interesting, you see, here we were calling background and passing a tint and saying this should be rendered in a shape. And now it's still called background, but it's a different version of it. It takes different arguments. This is what is called an overload. I talked about it last time. And so what they call the variant is an overload. And so with this variant of background, you can use an arbitrary view. In the following steps, you'll use that flexibility to alter the rounded rectangle's colors. Because here we could only pass something that was that they call a shape. So we could only pass a shape, not any kind of views, whereas with the other modifier, we can. What's interesting is that this modifier here was introduced probably with iOS 13. Let me check. Do they say availability somewhere? No. Let me just scroll up until I see the parent declaration. I hope I will. Okay. So this one was iOS 15, actually, because the other modifier, the one where you pass a view, it was introduced a bit later than the. At least that's how I remembered it. So this one, which OS is it? Okay, it's 15 also, but it's nice to see that there is a typo actually in Apple's documentation. So it can happen also for the best. And so, yeah, back to the topic. Yeah, so what I wanted to hint at is that not all modifiers are available on all versions of iOS. And so this modifier background, for instance, is only available on iOS 15. So if your app needs to support older versions of iOS, you won't be able to use it. To be fair, if you start a new app today, I don't think you will want to support versions of iOS before iOS 15. Currently, we are at iOS 17 and 18 will be released quite soon. So if you start an app today, it's likely that you will support 17 and 16. Maybe go all the way to 15 if you really need to have a large compatibility, but going all the way to 14 is going to be more rare. There are apps that have to do it, typically apps that are for the public administration, where you need to support many devices, or services which are like very important services for people, like electricity, banking. These kind of apps, they tend to need to support a large array of versions of iOS, because it's kind of a problem to say to someone that cannot update their device anymore that, well, you cannot use your banking app anymore unless you buy a new phone. It's gonna make people angry, and if you're a bank, you might even get like some bad headlines in the press. So that's one of the reasons why some apps need to support a lot of older versions of iOS. I don't recommend that you support like all the way up to iOS 14. But my point was, be aware that there are some modifiers that are not available to use on all versions of iOS. However, if you attempt to use a modifier that's not available, if you attempt to use a modifier not available on the versions of iOS that your app says that it supports, you will get an error in Xcode, which is kind of nice because originally in Objective-C, at the very beginning, you didn't have these kind of warnings and you could get a crash without being aware of it. So that was one of the fun things of building apps back in the days. Okay. And then we're going to reduce the opacity of the card I see a question. How are you invoking that history on the terms from Apple? So you mean how I go from this view here to this view there, for instance? I do command click. So command click here, and it shows me the place where the symbol was declared, which is the header of SwiftUI. SwiftUI is not open source, so you cannot see the implementation, but you can see the header that Swift imports and that allow you to use the features of SwiftUI. And so it's command click or it would be right click and jump to definition if you want to do it without the shortcut. That's how you do it, and it's a very, very useful shortcut. By the way, I have an entire video called, I think, like 65 tips to use Xcode like a pro, and you can check it out after if you want, and you have a lot of tips to use Xcode like a pro, as the name does suggest. Fair warning, half the tips, I discovered them while doing the live stream, so you can be a very good developer without knowing all of the tips in the live stream, of course. And so we're going to reduce the opacity of the card, so this thing here, and we do it by calling the opacity modifier, but we don't do it on the view itself, but only on the background, because we don't want to reduce the opacity of the image and of the text. We want it to stay super legible. And you can see that now it looks a bit more muted, maybe a bit too much, but we have an opacity of 25%. So the color is only 25% opaque. To say it differently, it's 65% transparent. And opacity values range from 0, fully transparent, to 1, opaque. So yes, so it was, so 65% transparent, yes, I was correct on that one. So try different values until you find an effect you like. So for instance, 0.5 is like this, 75 is like this. To be honest, I find 0.25 quite strong. I would more go for something like that. But remember, I'm not a designer, but the contrast feel quite too low. Like I feel like it's hard to read the text, and here it's more easy to it's easier to read. I'm not sure which is best, to be honest. Okay, moving on. For a final touch, bring back the contrast. They mentioned contrast, so I was not that much saying things that didn't make sense. By reducing the brightness of the card background. So we're going to play on the brightness. So put it at minus 0.4. So I will put it back to 25 and then like that. Yes, much better. So playing on the brightness. Kind of reminds me when I'm doing my thumbnails and I try to play on the color of the text, what it looks like nicer and more readable and more appealing. Similar stuff. I had never used the brightness modifier, to be honest. What does it say? So a value between, by the way, I did that by doing Alt-click this time. A value between 0, no effect, and 1, full white brightening that represents the intensity of the brightness effect. What's nice is that they say a value between 0 and 1, and we passed a negative value and it still did something. So this is not a great documentation. So use brightness to brighten the intensity of the colors in a view. The example below shows a series of red squares with their brightness increased from 0, fully red, to 100% white in 20% increments. So actually it's rather than, you cannot go to above 100 and below 0 in brightness, but you can increase it both positively and negatively. So actually this documentation here is not incorrect, but it's incomplete for sure. So it also shows how hard it is to correctly document an API, whatever that API is. So let's see what they say here. -1 to 1. So brightness values, here they say it correctly. So also being able to stay consistent between the documentation you write and then the tutorials you write around the documentation is also another challenge. Like I'm doing that at work. I've been doing that at work in part for the past few months, and I can tell you it's definitely a challenge, and it's so easy to have everything go out of sync because there is no compiler to check that you are doing the things correctly. You know, like you change something in a web page and then you don't change it somewhere else. You're not notified, but it gets confusing for everyone really fast. And so brightness values, they range from -1 to 1. Negative values blend black into the view, and positive values blend white into the view. So one brightens and the other one darkens in a way. So brightness with a negative value is darken in a way, which kind of makes sense when you think about it. So try both positive and negative values to see how it works. And as always, keep editing the design until you like it. So if we remove the minus sign, for instance, it's brighter this time. and now it's darker. And if we do, for instance, minus like 84, it's way darker. It's so dark that it almost becomes like pure black, and we lose the fact that there is this purple color to it. And about how you find the correct value, you see here they say like keep editing until you like it. I'm sure that designers have a bit more like rules or how do you call it? Something to approximate. I cannot remember the word. It's like I have the word, but I can't remember it. But it's when you have a rule that gives you an approximation that is good enough. Heuristic. That's what I was looking for. A heuristic to know which colors are what colors are used. I see an interesting comment, which I think is worth. Rule of thumb also. Rule of thumb, definitely. Rule of thumb is heuristic, but said in a way less like academic fashion. Heuristic feels more like I know what I'm doing. That's why you can trust me as a designer. I see an interesting comment that says what you are doing is a toy for kids. That's something I want to address, because this is a beginner tutorial, and the goal is not to show you and the goal, you're going to get banned very soon, by the way, but the goal is not to show how to build a complex app. I'm not going to show you how to build Uber in this live stream. The goal is to show people how to really get started with Swift. It's like introductory classes. Imagine you start learning computer science. You're not going to start from zero to build Instagram with the same features and performance and everything. And good remark, said in quite a mean way. So first time I used the ban button on for another remark that was quite mean. So first time I used the ban button on my streaming software after 3 years of doing live streams. So it's quite nice that it took that long. But hey, there is a first for everything. Okay, so actually this took way longer than I thought. I thought I would cover like 2 chapters in 2 hours. I will only cover this chapter because like my voice is already starting to kill me. So I will stop here. I will do the quiz first and then the recap on the page after, and then we will stop here for today. So like on the previous chapters, 3 questions to check our understanding. If you're watching the replay, try to pause and think about the answer because it's a great way to know if you've understood everything. So question 1, what's a good technique for inspecting the size of a view? ZStack, Size Inspector, or Border? So there is one we didn't use, Size Inspector. As far as I know, it doesn't exist. At least I've never used something with that name. ZStack is not what you use for this. ZStack is used in order to position several views from the back to the front, axis on the Z-axis. And we have border, the modifier that shows a border around a view. And it's indeed quite useful because it allows you to see the space occupied, the area occupied by a view. So border here is indeed the correct answer. And I think there might be a shortcut somewhere in Xcode to see, at least in the simulator, I know there is one, to show the space occupied by the views. If there is one, I've covered it into my other live stream about 65 tips to use Xcode like a pro, because it rings a bell. I don't remember how to do it exactly, but it rings a bell that, so if it's in the video, it's there, and there are chapters, so you will be able to find it quite easily if it's there. Question 2, in which direction do spacers expand to push other content? So in the direction of their containing stack, perpendicular to the direction of their containing stack. So now it's in the direction of their containing stack. So in an H stack, a spacer will take space horizontally, and in a V stack, it will take space vertically. And you can give an argument to a spacer, I think, to say mean width. So to say like, don't take, I think it's mean width. I'm not sure if it's mean width or max width actually. It's mean length, yeah. Same idea than mean width. It's to say that the spacer should take that much space or more. So it's similar in the UIKit world when you have a constraint that is greater than or equal. It's the same kind of logic. Interesting. By the way, border is always inside, not around the edge, where half the line width would be outside of the view. I'm not sure, actually. I'm not sure. You know what? We can check it. We can check what are the arguments we pass to border. I think it's. I think the border by default is in the middle, but I'm not sure. It's worth checking because indeed, when you draw a border, since the border, I mean, if the border is 1 pixel, in a way, I'm not sure it applies when the border makes only 1 pixel. But if your border is, for instance, 4 pixel wide, the question is, where do you draw the pixel? Do you draw all 4 pixels inside the border? Do you draw them outside the border, or do you draw half inside, half outside? So in softwares like Sketch or Figma, you have a choice in the UI to say if the border should be inside, outside, or on the center. And I'm sure there is a way to control that in SwiftUI somehow. I'm not sure how it works, to be honest, but great remark. Because ideally you would want the border to be, I guess, at the center. I guess it's the best way to see the space that the view occupies. But at least what you want is for it to be consistent, because otherwise it's gonna be super confusing. But very, very good point to mention it. Then what do I see? Yes, you're right. You can use the design button in the canvas, which sort of creates a border on the views based on what you click on. So yes, I showed it, this thing here. So this thing, indeed, it also shows a border around the ideal size, or rather the size occupied by the view. And if it had an ideal size, it might be that is the actual size occupied, but the ideal size is used to determine the actual size, but it might not always be equal to it. For instance, if there isn't enough space to render a text and text gets truncated, then the text is rendered in a size that is smaller than its ideal size. And then you say, yeah, you can overlay a rectangle. Yeah. When I said that you can always find a way to do it, I was thinking about this kind of stuff where you can always compose shapes in a way where it will do what you want it to do. But yeah, actually, I'm not sure if there is an API. But as you said, you can build one yourself. And so here, to go back to the question, in which direction do spacers expand to push other content in the direction of their containing stack? And a spacer helps you separate elements in a stack by pushing them away, and it can also help you make a view take all of the space available. Be careful, don't necessarily add a spacer by default, because there are some views, like for instance, we saw the tab view, that will take all of the space available by default. And it happens often that the parent view in a view hierarchy will take all of the space available by default. So don't use spacers until you actually need to. Don't sprinkle them everywhere because you think that you need them. If you don't really need them to make your view work, it's better not to put a spacer that actually doesn't serve any purpose. Because remember, any code that you don't write cannot have bugs. Unlike code that you write, which can have bugs quite easily, actually. And wouldn't you say using frame max width, then setting an alignment is better than spacers? That's quite a debate, actually. That's quite a debate. Personally, I think I was using. I don't do SwiftUI in a day-to-day basis since the last months, but I was moving more towards using frame with max width and max height and alignment, to be honest, especially when you want to center, because when you want to center, you need to put a spacer on the left and one on the right. It can be a bit annoying. So the frame one is a bit more powerful, and also the frame one, you can use it in very interesting ways. Like for instance, if you want to center a content, you can try sometimes to put the content in the background of a view and then center it with the frame, with this frame modifier. So it's not super clear the way I've described it, sorry, but the bottom line is the frame is quite powerful. And I would say when you're getting started, spacer has the advantage of being very easy to understand what it does. But as you're building more and more complex views, indeed, using frame max width or max height can indeed be a solution that scales a little bit better. but both are supposed to be equivalent anyway. So in the end, it's more a question of preference and coding style. And so, question that seems actually quite a link to this: how can you create a frame with infinite height, or rather with infinite max height? Because if you try to set infinity for the height, you will get an error because it must be an actual value. So use the infinite height frame modifier. I don't think that exists, even though you could create one if you wanted to, that would, under the hood, call the correct one. Use the frame modifier with a max height argument of infinity. Use the frame modifier with a height argument of maximum. So this one, don't do it, you will get an error. But this one, indeed, is the correct one with the frame. So min width, ideal width, max width, min height, ideal height, max height alignment modifier. That was a mouthful. You can create many kinds of flexible frames by choosing just the arguments that suit your needs. And you're saying, yeah, same here. I usually create a custom func which accepts the element parameters that way. I don't have to always include spacers or type in frame max width. So yeah, in the end, it becomes more a question of style. And I would say the more important criterion for me is that whatever you choose to use, you use it consistently into your code base. Like, what's bad is to do spacer in some places, frame max width in another place, a custom modifier in yet another place. Choose one approach and do it everywhere. It will always be better than doing a little bit of each in different places. But creating your own modifier is also absolutely on the table. All right, wrap up for this section about layout and style. So SwiftUI's layout system has a few simple rules, but its ultimate behavior can be complex, because even from simple rules, you can make a quite complex system emerge. By combining stacks, spacers, and padding, you can build expressive interfaces. So what have we learned? We've learned that SwiftUI provides a range of container views that group and repeat views. You can achieve the layout of any app interface using containers, such as stacks, along with views and modifiers. Going beyond what you saw in this tutorial, you can also use SwiftUI to ensure that your interface adapts dynamically to a wide range of traits and contexts, including different device screen sizes, resolutions, and color spaces, different device orientations, portrait or landscape, split view. I could also add light mode and dark mode, for instance. Which topics and skills have we covered? So debugging layout issues using borders, so very basic but still useful debugging skill. Adjusting the sizes of elements using frames. Using 3 types of stacks, VStack, HStack, and ZStack to create a complex interface. Controlling the placement of content in a stack with spacers. Navigating between views using a paged tab view. And custom color sets in the asset catalog. And I think that covers it quite well. We had already seen how to create like child views in the previous chapter, so we just used it as being part of our toolset. And yeah, that was quite a good lesson already. That's quite a good curriculum for this lesson. So if you want to keep practicing on what we've learned, so you can extend the app we've built either by playing with the design of the app, so trying to use all the techniques you've learned, such as padding, spacing, and stack layout. How much can you push the design in a new direction? How much can you accomplish with additional nesting of stacks? And remember, you can also read the document called Apple, the Human Interface Guidelines, to know how to build a UI that will be in the guidelines of what an iOS app should look like. You can try to add a third page to the onboarding flow, including whatever elements you want in the new page. Or you can try to change the color scheme of the app. You can update the True Gradients color or add a third. Try varying levels of opacity and brightness to make the feature cards different from one another, like we tried to do a bit during the tutorial. And if you're more in the mood to challenge yourself, you can practice swiping between multiple views. So start a new Excel project and create a short story using tab view style page, so you can swipe between the pages of your book. Make the first page look like a book cover, including a large title, author name, one or more SF symbol, and some splashes of color. For the pages in the story, think of creative ways to display chapter titles, text, and pictures. And you could even get the text of a book that is like in the public domain to try it. And I see a question, so I will answer it. Quick question: if we add fixed heights to our components in our view, would that mean the sizing will be off in different devices? So we use Geometry Reader to fix this. Very good point. Very good point. If you put a fixed height, then you might have a problem that maybe you don't want the same height in all devices. Maybe you don't want your view to be of, I don't know, like 400 of width. What you actually want is your view to be 80% of the width of the screen. And indeed, when you need to read the size of the screen, you have a type that's called the geometry reader that allows you to do this. And basically, whenever you need to express a size in a way that is relative to that of the parent view, which could be the screen when you are at the top level, then you will need to use a geometry reader. So think about the constraint that you could do in UIKit of saying I want this view to be 60%, so 0.6 the size, the width of this other view. This is how you would do it through a geometry reader. We haven't covered geometry reader in this tutorial. Maybe we'll cover it in the next chapters. I don't know. But thank you for mentioning it, because if you're looking for a way to build more complex and powerful interfaces, geometry reader is definitely something that you're going to stumble upon, because it's quite powerful. And basically, to say it in a nutshell, geometry reader is a way for a child view to access the size of its parent view, and this way be able to say, okay, I want a frame that is 0.2, so 20% times the size of the parent view. And you're saying, and you're able to combine proportional max and mid values with fixed minimums. Yes, in that case, yes, you can indeed combine the two of them, and maybe even build a nice utility in order to do it. Sometimes you won't even need to actually code the minimum, because most of the time that minimum will actually be given by the ideal size of the views. For instance, if you have a text being displayed, well, the minimum size is for the text to be readable, so not to be truncated. So sometimes you will indeed need to define these minimum sizes, but most of the time you might not need to, because you will define a max width, for instance, and the max width, you will not need to define a min width, because it's kind of given automatically for you because of the ideal sizes of the child views. When the child views don't have ideal sizes, typically if they are shapes, for instance, then you would indeed need to also provide minimum value. Thank you, that was a very good remark. And they also say if we want to change ourselves, we can enhance the chat prototype. So the app we did in the first chapter, you can go back to your chat prototype project. Can you work out how to push messages to the left or right edge of the screen to indicate whether they're from the person using the app or the person they're talking to? Hint, if you have a custom view for the chat bubbles, you can use if statements inside stacks to conditionally include views. That could be a pretty good change, and not that, I don't think it's that hard. So this one is much easier than the one above, and you can indeed try this one first. And you're saying, I hardly use minimum size. It's a rare occurrence where you need it, in my opinion. Yeah, to be honest, I don't think I've ever needed to use it. And the ideal one, same, because most of the time there's going to be one by default. And basically, I think in the cases where you don't have an ideal size, then you want the default behavior, which is to take as much space as possible, and you put a frame in order to a frame with an actual height or width in order to constrain the thing. So indeed, I concur. I don't think I don't recall using min width or min height in production ever, to be honest. Okay, and what will be next? So next week, in the next tutorial, we will learn how to create views that have state, and learn how to make our app interactive using buttons. So state and buttons, it will be next time. So sorry, I know someone was stuck there. It will be for next week, next Monday. But I'm really glad that we covered this chapter. It was 2 hours in the end. I didn't think it would be that long, but it was quite thorough. And I think for someone that is discovering SwiftUI, we've covered a lot of the groundwork. And now you have the foundations, and you also have a few ideas of where to look to go for something a bit more complex. So I think once again, Apple did a really great job with this series of tutorial. And so I see some nice messages in the chat. So thank you for the people who were there during the live stream and who made really great remarks and asked really great questions. I'm sure that the people who are watching the replay appreciate your effort. And for me, it also makes it feel much more interactive than if I were to speak in my empty office, in my empty home office for 2 hours. So thank you a lot. And I guess I just have to say, yeah, see you in 1 week for the next part of this tutorial. If you're watching live, if you're watching the replay and everything is already recorded, you know, it's just like for a TV show, you can binge watch and just move on to the next video. Thank you for watching and see you next time. Bye bye.